I captured the sunspots with my Newtonian reflector telescope and smart telescope. The Sun is an enormous object that provides heat, light, and energy through a process called nuclear fusion. It has a diameter of about 1.4 million kilometers, which is approximately 109 times the diameter of Earth. Solar activity on the Sun includes phenomena such as sunspots, solar flares, and coronal mass ejections (CMEs). These events can have an impact on Earth's space environment, causing phenomena like the northern and southern lights, auroras, and occasionally disrupting satellite communications or power grids. Sunspots, also known as solar spots, are dark regions that appear on the surface of the Sun. They are temporary phenomena and are characterized by lower temperatures compared to the surrounding areas. Sunspots are areas of intense magnetic activity on the Sun's photosphere, which is the visible surface of the Sun. This shows one of sunspot comparing to the size of Earth. I pointed my 130mm aperture and f5 focal ratio reflector telescope at Sun. We should never point our telescope directly at our Sun without a proper solar filter. I have made a separate video about the cautions and danger if we use telescope without a proper sun filter. This video link is pinged in description. As of NASA's data from 22 and the 23rd of May 2023, the sunspots are given these numbers. Let us have the view of the Sun captured through 10mm focal length eyepiece. The sunspots appear dark because they are cooler than the surrounding areas. The average temperature of a sunspot ranges from about 3,500 to 4,500 degrees Celsius, while the average temperature of the Sun's surface is around 5,500 degrees Celsius. Sunspots are caused by the Sun's magnetic field becoming twisted and concentrated in certain areas. They often occur in pairs or groups, with a leading spot and a trailing spot. The leading spot has the opposite magnetic polarity compared to the trailing spot. Sunspots can vary in size, ranging from small spots less than 500 kilometers in diameter to larger ones that can be several times the size of Earth. They can persist from a few days to several weeks before gradually dissipating. Now, with my smart telescope and its solar filter, let us capture the Sun and sunspots. The study of sunspots is important for understanding solar activity and its effects on space weather. Sunspot activity follows an 11-year solar cycle, with periods of high and low activity known as solar maximum and solar minimum, respectively. During periods of high activity, sunspots are more frequent and can be observed more frequently on the Sun's surface.